Okay, now I suppose you have downloaded a PDB file. For example, in this case, I have downloaded a PDB file with name of 1brs.pdb. This is a protein complex of barnase and bar star. Okay, so first, before we go into the details of the arc, let's first see what is a PDB file. So this is the format of a PDB file. It's a text file. It has a header, some title, compound, source. So these are the information for a protein structure. The most useful information in this file is the atom information. For example, this first line of atom, it's the first atom in this protein. It's a nitrogen atom, and the residue of this atom is valine, and the chain ID is A, and here is the residue number. So the residue start with 3. And here there are 3 numbers. It's the X, Y, Z coordinates of a PDB file, or of an atom actually. So for each atom, it has the X, Y, Z coordinates. So if you have all the X, Y, Z information of all the atoms, then you can visualize the structure. And you can also do some calculations based on the structure of the atoms. Here are some other informations we don't use quite frequently. Here is the atom type. It's nitrogen. So the second atom is here, carbon C alpha, carbon alpha atom. The third atom is carbon, and then hydrogen, carbon beta atom. And for each atom, the most useful information is here, X, Y, Z coordinates. Okay, so in the future, we're going to learn some software which can visualize the PDB structures, such as VMD, Camera. They're both good at showing structures of PDB files, but we'll learn it in the future. In this class, we're going to handle the PDB file by using awk to do something with the record of atoms in this file. Okay, so that's the basic format of PDB file. Now let's get back to awk. The first usage of awk, print $0 means print all lines for this PDB. So in my, it's not the slides, but in my document, it's PQR file. However, when you download it, it's a PDB file. There's slightly difference, but they are very similar files, so we can use PDB file to do the same thing. So now let's print all lines, AWK, awk. The usage of awk is AWK, single quote. In the single quote, you can use a curly bracket, and then inside the curly bracket, you can do something. So the first thing we want to do is want to print something, some information, which is the basic information. $0 means everything in a line. And then followed by the file name, 1brs.pdb. Then the whole line, the information of a whole line will be printed out for each line, which means everything in this file. That's the first basic usage. But sometimes we want simply, for example, output the X, Y, Z coordinates. Then we just want output 1, 2, 3, 4, 5, 6, 7. this is the 7, 8, 9 columns. Then what we can do is we can arc print $7, $8, $9 for this file. Then that's the XYZ coordinates, or that's the 7s, 8s, 9s columns for each line. Okay. So the basic usage of print in arc is, if you want to print some columns, then you can just indicate the column number with a dollar sign. For example, $5 means the fifth column in each line. But one special thing is $0. $0 means the whole line with all columns. Okay, let's see some string operators. So for some string operators, you can get information of the length of a string. You can also get substring. You can use arc to do these things, such as, first, let's get the length of a string. Let's use arc. First, let's print $0. And then let's see what's the length of the whole line for each line. Length. If you want to check the length of the entire line, that's $0. Let's see the length of $0 followed by this file name. Then what you get is, so at the end of the whole line, because remember our command, we first print $0, then we print the length of the whole line. So the $0 is from here to here. Even there are some spaces, still it's the part of the line. So for each line, we have 80 characters. For example, even for the last line, it seems like only 3 characters. However, actually, it has some spaces. So totally, it has 80 characters, including the spaces. Now let's do another check. Let's check $1 means the length of the first column. Okay, this time it's different. For example, the first column of this line is E and D, so it has 3 characters. So for this line, the first column has 6 characters. So this is the way of checking the length of some strings. Now let's see the second usage, substring. Okay, sometimes you want to get some substring from a whole string. For example, if we want to get the substring, let's say the first 4 characters in the first column, then what can we do? Again, let's first print $0, the whole thing, and then let's use substring to get the first 4 characters in the first column. Let's say it's the first column. You need to first indicate which string. So the string is first column, and then we want the first 4 characters. So we need the start position. It's from the first characters, and then we need to indicate how many characters do we want. We want 4 characters. Okay, then it's printing the first 4 characters. For the last line, it only has 3 characters in the first column, so you have 3 characters here. But for all the other lines, you will get the first 4 characters in the first column. You can also get substring from the whole line. For example, if you want to get the first, let's say, 50 strings in the whole line, what we can do is, okay, this time let's do not print $0. Let's print substring $0 from the first to 50th character. Then you will see it doesn't output the whole line. Instead, it output the first 50 characters. So this is the substring function. Next, printf. So printf function is used for formatting output. If you have ever learned C or C++ or similar languages, you will be very familiar with printf function. So it's a format output. So the usage is very similar to C++ or C. So you print f, then first the parentheses. In the parentheses, you have double quote. That's your format, and then it's followed by the items you want to output, and those items will replace or substitute some format in the double quote. So first, let's try an example. You will understand it better. We'll still use this file, but this time we're not going to print something. Instead, we are going to print f something. When you use printf, first you need parentheses, then double quote, comma. Now, first, let's maybe print the XYZ information, which is dollar 1, 2, 3, 4, 5, 6, $7. Sorry, $7, $8, $9. That's the XYZ coordinates for each atom. In the double quote, you want to specify which format do you want. You can output in different format. For example, first, the types of data. The percentage I means integer. Percentage D also means integer. So percentage C means characters. Percentage S means string. Percent F means floating numbers. And in floating numbers, you can also specify what's the accuracy of the floating number you want to output. Okay, let's try. First, let's try percentage F, percentage F, percent F. One thing we need to know is in printf, it doesn't change lines if you don't add a new line sign. So here are some special characters like new line. It's /n. /t means tab or table. /b means backspace. F means something else. So first, let's use the new line sign here. So in this format, you will print 3 floating numbers. Those 3 floating numbers are from $7, $8, $9. And after print the $7, $8, $9, you will have a new line sign. So it will change line. Okay, now let's see. So here, that's the information. For example, that's the XYZ coordinates for some atoms. For the last two lines, they're not because they're not atoms. There are some other lines. So by default, the accuracy is really high. It's let's see, 1, 2, 3, 4, 5, 6. So it's a 6 digit after the decimal point. It's too high. If you want to lower the accuracy, what you can do is it's similar to some other language. You can indicate that I want it to be 8.3 floating numbers, means the length of the number is 8 digit and the digit after the decimal point is 3. So that's the accuracy. 8.3, 8.3. So if you count the digit 1, 2, 3, that's 3 digit after decimal point, 4, 5, 6, 7, 8. So it occupies 8 characters. The similar things are shown here. 1, 2, 3, 4, 5, 6, 7, 8. So the length of the floating number is 8 and 3 digit after the decimal point. Of course, you can change let's say, the accuracy. For example, if the accuracy is 2 digit, let's see, now you have 2 digit after the decimal point, and still it occupies 8 characters. But remember that you need a new line sign to change the line. If you don't have this reverse /n, it doesn't change lines. So let's try this. See, it doesn't change lines. So you have all the numbers in just one line. Okay, so this is the usage of the printf function. You can also try %d, which means integer. Maybe let's try integer here. First, let's add the reverse slash. %I or d, I or d, or d. Okay, now we want to print $789 to be integers. Let's see what will happen. So it becomes integers. It just ignored the digit after the decimal point. And of course, you can also print the information in other data type, like floating numbers or other like strings or other format. So the most commonly used format are shown here. But you may notice one problem, which is, okay, which is when you print such information, $789, actually, for example, in the last two lines, they're not XYZ coordinates of atoms, because in the original file, if we look at the original file, let's go to the end, you will see at the end, the last two lines are not atoms. There's some other information. So what we want is the XYZ coordinates for atoms. So this is heat atom or special atoms, but they're still atoms. It's an atom for oxygen in water. So these three columns are really XYZ coordinates. However, 1, 2, 3, 4, 5, 6, 7. These three columns, they're not XYZ coordinates. So we want to just get XYZ coordinates from either heat atom or, let's see, there are two types of atoms, or atom. So if you see atom or heat atom, then let's output the XYZ coordinates. Otherwise, they are not really atoms. So we don't want to output them. So what can we do is we can use the search pattern. For example, if $1 is atom, then we output something. Okay, now let's try. So this time, let's print $7, $9, $8, $9. But let's add if statement. If $1 equals to atom, then we print those information. Now you see, there are XYZ coordinates. But actually, as I said, there are two types of atoms, atom or heat atom. So we can consider both of the case by using or. If $1 equals to atom, or double pipe means or $1 equals to heat atom. Then we print $7, 8, 9. Okay. Let's do a comparison. So let's first print $0, then print the $7, 8, 9. Then here you will clearly see when it's heat atom, it's outputting the XYZ. And when it is, for example, atom, it's outputting the XYZ. Otherwise, it doesn't output anything because we use the if statement. So here, this double pipe means the or operation. It's similar to C language. If you want to use AND operation, you use double AND in your if statement. So here shows some operators like or, and, not, less than, etc. Okay, so for example, this time, let's try to output information for oxygen only. So let's see. If you want to do this, we want the atom, but we want the information is from atoms, and the atom type is oxygen. What we can do is first, if $1 equals to atom, and let's see, 1, 2, 3, $3 equals to oxygen. In this case, we output the whole line, $0, and then XYZ. Okay, now see, if it's atom, if the third column is oxygen, then the information is output. Otherwise, it doesn't put any information. So that's the usage of if. You can also try to do some more complicated operations, like if something is greater than a number, or and something is less than something, the output. So that's the basic usage of using awk. I mean, using if condition, then you do something. And you can also add some else if else to do some other things. So you can try those more complicated operations after this class by yourself. Please try else if. else. And let me know if you have any questions about the logical operators. Here are some internal variables which are very useful. Sometimes you need to use them. File name. Now let's try to see what is file name. So let's make it easy. We don't have any if statement. We just print the whole line and file name. File name. Then you will see at the end of the whole line, it outputs the file name. So this capital file name is the internal variable for the current file name. Another useful thing is perhaps the number of field, which is NF. Let's output the number of field. So for example, in the last line, number of field is 1. You can try to take the number of field to be number of columns. How many columns does it have in the whole line? So in the last line, it has only 1 column, which is end. In this line, it has 13 columns. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So for other columns, for other lines, it has 12 columns. So it's also useful sometimes. And the number of record, let's see, what is the number of record? In R, number of record. So that means the number of lines. So totally you have this many lines. That's the line number. And some other internal variables are shown here. You can try them by yourself. Okay, next, some arithmetic operators. Addition, subtract, multiplication, division. Okay, let's make an example of what's the sum of x, y, z. So what you can do is you can print $0 and you can also print $7 plus $8 plus $9. Then what you can see is at the end you have the sum of the 7, 8, 9 columns. I know if you add x, y, z coordinates, it doesn't make any sense, but it's just a practice of using this size. You can also do something like, perhaps let's amplify the x coordinates by 10. So you can use $7 times 10. So it's 10 times greater than your original x coordinates. For example, here x coordinates 27 something. So here you have 270 something. It's 10 times. So that's another operation. You can also do other mathematics operations. Okay, variable. You can introduce some variables in arc by this format, arc-v, then define a variable equals to a value. Now let's see. Arc-v, let's define a variable, which is sum. This time we want to calculate the sum of x coordinates. So first, let's sum equals to 0. Then what we can do is, let's say if $1 equals to atom, or it equals to heat atom, then sum equals to sum plus let's say $7. So that's the x, sum of the x coordinates. And then let's print $0, print $0 and sum. Okay, and this operation will be done to the 1brs.pdb. So here you will see, okay, so here you will see, oh, there's something wrong. So because now after the if statement, we have two operations. The first operation is do a sum. The second operation is print something. So you need to use a curly bracket to quote these two operations, indicate that if this is true, then you do the two things. Otherwise, if you don't use this curly bracket to quote both of them, then if this is true, it only do the first operation. For the second operation, no matter what happened, it will run. So it's not in the if statement. But now if you use the curly bracket, then everything is in under the if statement. Okay. If it's atom or heat atom, you will first print everything and then print the sum of the x coordinates. That's the sum. Okay, so that's the usage of using a variable. Of course, you can define several variables. For example, we can define another variable, which is perhaps n. Then you need to use dash v again, n equals to 0. Let's use n for the number of atoms. So every time, if it's atom, let's add 1 to n. And then let's print n. So what you see here is if it's atom, then you're adding the x coordinates to the sum, you're adding 1 to n. So finally you can print $0, the whole thing, and then the sum of x coordinates, and then the number of atoms. Here clearly you will see totally in this file it has 5,153 atoms, and the sum of the x coordinates is this number. If you want to calculate the average position of the atoms in x direction, then what you can do is you can use sum over n. So here, that's the average position of all atoms in x direction. For example, if you want to calculate the average position of all atoms in x, y, z directions, or the center of mass, approximately the center of mass of this atom, what you can do is you can use similar ways to calculate the average value of x, average value of y and z, and then that's the center of mass, approximately. Okay, begin and end. So in awk, by default, everything is operated or executed for each line. For example, you do the sum, you do the n++. So it's based on line. So for each line, you do the same thing. For each line, you first check if statement. Then if this is true, you run the commands. If it's not true, it doesn't run anything, but that's for every line. Sometimes you want to do something before the first line or do something after the last line. Then you can use begin or end. So let's try to use begin. For example, begin, followed by this curly bracket. Let's say begin. At the beginning, you want print hello. Let's print hello. And at the end of the last line, you want print hi. Hi. Okay, then you will see at the end, it's print hi. It's difficult to check the beginning, but at the beginning, it will print hello. It's difficult to check, but let's output it into a file, temp.txt. Then let's visualize temp.txt by vi. At the beginning, you see hello, and at the end, you see hi. So that's the thing you want to do at the beginning and the end. So this is the usage of awk. You will have two homeworks. First, calculate the center of a protein using similar ways were shown here. It's not an accurate way to calculate the center because you have different atoms. The different atoms may have different mass. However, let's ignore this trivial things. Let's just calculate the geometry center of mass approximately using the similar way. Number two, calculate center of all the proteins. Let's say, let's say 5 proteins. Please download 5 proteins and then calculate the center using your script to calculate the center of those 5 proteins. One thing I want you to use in the second test is try to use a loop. We have learned for loop. Try to use a for loop in the script to calculate the center of proteins because it's a 5. You can run your program 5 times. However, sometimes if you have 50, 500, or 5,000 proteins, you don't want to run it 5,000 times. You just want to use a loop. So the second test is for a loop, for using a loop. So that's a good practice. Okay, so that's all for today's class. I'll see you next time. Thank you.